So we will start first with set theory. زين. What is meant by set theory? So set theory. Set theory is the idea of how to deal with having a set. A set can be anything from numbers, like 1, 2, 3, or letters, A, B, C, or even words. يعني, I don't know, Ahmed, Salim, Fatma. All right, these are all considered sets. All right, so a set can be anything. It can be a combination of anything, as long as it is you are able to define that thing. So the way I just wrote these sets, yani for example, let's say this is A is equal to 1, 2, 3, B is equal to ABC, and C is equal to Ahmed, Salim, Fatima. So this is called the roster method or the listing method or the tabular form as well sometimes of how to name or identify a set. There is another way, all right, which is called using the set builder. So this is the roster or listing method. So it's by, building a roster or listing them one by one. So the other way is by set builder or rule method. All right. If we take the same examples as the above ones, we just draw this. So A, we can say, for example, is X, where X is the first 3 positive integers. Then, so this means the exact same thing as this. What does integers mean? Integers mean 1, 2, 3, 4. Basically numbers without decimal points. Those are integers. All right. So integers basically mean 1, 2, 3, minus 1, minus 2, minus 3. These are what integers are. Positive, I think everyone knows what positive means. It means it's greater than 0. All right. It's greater than 0. And then we have the first 3. So the first 3 numbers that are greater than 0 that do not have decimals. This is the same as saying 1, 2, 3. All right. So this way it's called the set builder or rule method. It is also another way of identifying a set. يعني تقدرون تكتبون الكلام اللي هو معنى الأرقام إنزين. So it's basically the words that mean the same thing as writing the number or the set value itself. This is also acceptable as a way of identifying a set. All right. Now, so there are a lot of different types of sets with a lot of different types of names, all right, for the sets. There's a finite set, infinite set, empty set, singleton set, equal sets, equivalent sets, so many things. These are just all rules. Then most of these, I would recommend that you go and look at the definitions and read them and understand them. Me, now I will directly go into solving such questions so that you guys get a better idea of how questions might or might not come in the exam. All right. So let us start with the first question. So these are all the student worksheets. I'm going to be solving student worksheets 1 and 2. All right. So which of the following are well-defined sets? All right. What does a well-defined set mean? A well-defined set means يعني you can properly understand what the set exactly means. يعني you can exactly write a set in the form of numbers or letters or names. So you can define the set between these parentheses and you can fill it up properly. يعني I cannot say a set is the amount of air around me, because I am not exactly defining how much air is around me. I am not defining what is the space that is around me. ما قاعد أعطيه limits. I'm not giving it appropriate limits. Okay, appropriate limits. For example, A, all the short boys of a school. Then this is not a well-defined set. لأن you don't know what you mean by short boys. We did not define short boys meaning less than 150 centimeters, or less than 180 centimeters, or greater than 50 but less than a specific amount like 100. I don't know. And for an example, we did not define this. So this is not a well-defined set. We cannot write it in this form. All the letters of the word statistics. This is a set because here it is properly defined all the letters that are possible. So if I would want to write this as a set, let's say B is equal to, we have the letter S, we have the letter T, we have the letter A, we have the letter I, and we have the letter C. All right? These 5 letters build up the word statistics. So we can write it in a way that it is a set. Again, the last one says all the hardworking teachers. We don't have a proper identification or a proper definition of hardworking. Yani, what is hard? How hard are they working? What is the number or the scale that they are using to define hard؟ فما في definition, proper definition. احنا نقدر نقول كان يتعب روح المدرس وايد كان يشتغل hours زيادة. All right, here, so we can say, for example, if they are saying greater than 9 hours of work, that's hard working. هني we can define it. This would be proper. زين, this would be well defined. But it is not mentioned, hence this is also not defined. So the only well defined set here is B. All right? That is the idea of a set, a defined set. Now, let's move on to the next question. Let A, E, I, O, U, all right, which are the vowels basically of the English alphabet. Let this be a set. Insert the appropriate symbol. Now, this symbol that you see here that looks like the letter E, this basically means whether or not something belongs in a set. So for example, let's use another example here. Let's say B is equal to 1, 2, 3. All right. This is a set. So we can use, let's say the number 1. The number 1 belongs in the set B. We can say it this way. This is what this means. The number 5 does not belong in set B. Why? لأن هني 1 it exists. Okay? The 5 here does not exist in the set. All right? So this is how you would use the belongs symbol, which is the E symbol or the belongs to symbol in this case. So here we have a set A is equal to A, E, I, O, U, which are the vowels of the alphabet. إنزين? So O, does it belong to the set? Yes, it does. This belongs to the set. U, does it belong to the set? Yes, it does. It belongs to the set. N, does it belong? Is there any N here? No, there isn't. So we say N does not belong in the set. All right? So N does not belong in A. Very simple. It's just a symbol you guys need to understand. When it's just by itself, it belongs. If it has a slash through it, it does not belong. Now, number 3, which of the following sets in Builder, write the following, sets in Builder notation. So remember, we have 2 notations. We have the basic, the roster or the listing notation, and we have the set builder notation. So these are given in the resting notation, right? So there are so many different ways you could possibly write these. And then an example would be for example, for part A, X, first things first, you need to define the function or the set. So it's already given as A. So A is equal to, then we open the parentheses, which is going to mention X, where in this case we could say X is an even number, all right? Because it is even numbers only, 2, 4, 6, 8, 10, 12, 14. So we can say that is between 2 less than or equal to X and less than or equal to 14. This is a way of writing this. There's a lot of different ways you can write this, but this is one of the ways. So this, what does this mean? This means that X is an even number. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All of those are even numbers. But it is between 2 and 14. ليش؟ لأن هني it ends at 14 and it starts at 2. So we make sure we include the 2 and the 14. All right? We can say that. Also, we can say, for example, the limit is between 1 and 5 and 15. ليش؟ لأنه we're talking about even numbers only. So this is also true. يعني you can write it in any way you want as long as it is properly defined and it mentions everything. For part B, it's all the letters of the alphabet. All right? So we can say that B is X, where X is a lowercase. لأن these are not the capital letters, these are just the small letters, so it's lowercase, not uppercase. Letters of English alphabet. زين؟ طبعا you're not going to have to write this. I assume there's going to be like options, multiple choice options. You just have to know what means what. In this case here, زين, it's January, February, March, April, May, June. So this is 1, 2, 3, 4, 5, 6. All right. So this is the first 6 months of a year. So for example, we can write C is X, where X is the first is one of the first months of the year up to the 6th month. For example, طبعا there is a better way of writing this. We could also say X is a month in the first half of the year. زين, again, there are many different ways you can write this. هني الفكرة إن you guys understand, you just make sure you understand what is set builder notation, what it means. So you're defining it by words, using words, not numbers. This is the ruler, what you call it, the roster or the rule form. And then you need to understand what it means, how you can convert it back and forth from this to that, basically. All right. Now we're going to do the exact opposite. هني we are given the roster or given the set builder notation, sorry, and we need to find the roster or the rule form. The consonants used in the word Bahrain. A. So we're going to say A is equal to, what are the consonants used? So consonants are the non-vowel letters. So we have the letter B, we have the letter H, we have the letter R, we have the letter N. So we can say A is B, H, R, N. This is what A is. This is how you would write the set in roster form. All right. I would definitely think they're going to bring a question either from roster to set builder or from set builder to roster. I'm not sure which one, but I have like a feeling that this is what one of the questions might look like. And then for B, even numbers between 1 and 9. So B is all the even numbers between 1 and 9. So we're going to write them down like 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to look at only the even numbers. So what are the even numbers? We have 2, 4, 6, and 8. These are the only even numbers between them. So the answer is going to be 2, 4, 6, 8. Tamam? Now the last one is the most important one, C. C is equal to, and then an X, where X is an element of N. When you see something like this, and this basically means N is the set of natural numbers, meaning it can be any number. All right? Meaning it can be any number. This is what a natural number is. So obviously they have to not be decimals, so they're basically the same as they're the same as integers. All right, so they're going to be 0, 1, 2, 3. They can be any number like that as long as it doesn't have a decimal point. That's what a natural number is. All right, now it says that X belongs, remember the symbol, it means belongs in the set of natural numbers. So it has to be one of these natural numbers. And the condition given to us is 5 less than x less than or equal to 12. What does this mean? معناته x can be 6, 7, 8, 9, 10, 11, 12. Why is it all these numbers but not 5? Because there is no equal sign here. There is no equal sign here. It's only greater than. There is an equal sign here, but there's no equal sign here. You need to know these simple, notations so you do not make mistakes. So it's going to simply just be the same thing over here that I just wrote down. This is going to be our final answer. All right? And this is our set. Okay? Don't get too confused when you see an element of n. All you should know is that if you see n, you know it's going to be whole numbers, and that's it. All right. So if it's an element of n or belongs to n, usually I call this element of element. Why do I call this an element of? Because each one of these are considered an element of the set. All right. These are elements of the set. Now, let's go to the next question. Question number 5. Write the cardinal number for each of the following. I have not explained what cardinal number is, so I'm going to take the opportunity to explain it now. A cardinal number is the number of elements in the given set. يعني, let's say A is equal to 1, 2, 3. Let's actually give it 2, 4, 6. All right, 2, 4, 6. So the cardinality or the cardinal number of A, it will be given in this way. N of A is equal to 3. What does this mean? It means we have 1, 2, we have 3 elements in our set. This is what the cardinal number represents, or the cardinality. زين؟ كم عدد elements اللي عندنا في الset? That is what the cardinal number is. All right? Very simple. This is the way you would write it down. And this is the case for if we have A over here. I'm going to keep this on the side. So let's actually solve the question now. So part A, why is the set of letters in the word mathematics? Then, one thing you need to know in a set, all right? Let's write the set down first. A set does not have repeating values, all right? A set will not have the number 2 twice, or the number 4 twice, or the number 6 twice. It will have unique elements each time, all right? So in this case, it's the same thing with letters. So it has the letter M, all right? It has the letter A, it has the letter T, it has the letter H, all right? It has the letter E, it has the letter M, but we already wrote M, so we're not going to write it again. It has the letter A, but we already wrote A. I'm not going to write it again. It has the letter T. We wrote it. I'm not going to write it again. Has the letter I. Yes, we did not write it, so the letter I. Has the letter C, and has the letter S. Okay? So now we want to find the cardinal number. Cardinal number is N of A, which is going to be, let's count them, 1, 2, 3, 4, 5, 6, 7, 8. 8. That's what the cardinal number basically is. It's the number of elements in a set. That's it. And then the next one, Q, part B, Q is equal to X, where X is an element of I is basically integers, minus 5 less than or equal to X less than 2. So how would we write this? We start from minus 5 because there's an equal here. So it's included. Minus 4, minus 3, minus 2, minus 1, 0, 1. Remember, there's a 0 after minus 1. 0, 1. And then that's it, because there is no equal sign here. An equal sign does not exist. So we close the brackets here. And now we can count them. N of Q is 1, 2, 3, 4, 5, 6, 7. So N of Q is 7. That is the cardinal number that we have. All right? All the sessions will be recorded, yes. If you guys have any questions throughout the session, please just type it in chat, and I will be reading it every now and then. All right. So, NQ. So, like I said, we just counted them from 1 to 7, and this is going to be the cardinal number. عيد بي هذا again. All right. Again, let me repeat this. You guys need to understand this very well. Just give me a second. Let me copy paste this. So I need you guys to understand this notation. It's very important in statistics لأن this is how they would write things, all right? فعندنا هني x, where x is an element of I, so it's an integer. Integer meaning 1, 2, 3, إنزين. And then we have this condition given. So it is going from -5 included, because we have an equal sign over here, this equal sign. All right, so it's included between x, and it's going all the way to the number 2. But there is no equal sign here. An equal sign does not exist. فمعناته x is not equal to 2, it's less than 2. But here it's equal to -5. So we're going to start from -5 and reach 2. So the first number is -5. Plus 1 after this is going to be -4. The number after -4 is -3. The number after -3 is -2. I'm just adding 1, 1, 1, 1 because they're integers. There's no decimals. Then there is going to be -1. Then there's going to be 0. Then there's going to be 1. And then there is not going to be any 2 because this is less than 2 and not equal to 2. There is no equal sign here. فخلصنا. This is going to be the set that we have, which is set B, or in this case it is named set Q. All right. This is how you find Q. Now, we just need to find the cardinality. That's the question. Then N of Q. And here you just count the number of elements. So عندنا 1, 2, 3, 4, 5, 6, 7. 7 7 elements we have in this entire set, which is the cardinal number. That's basically what it is. So for June, now R is Jan, June, July. All right, for part C, R is equal to Jan, June, July. Very straightforward. Already عندنا set. We just need to find the cardinal number. N of R is equal to, this is 1, 2, 3. We have 3 elements in our set, so it's just 3. All right? Very straightforward, very basic, nothing complicated about this. All right? Now, moving on to the next question. We're talking about equality. Then, are the two sets X and Y equal, and why are they equal? If they are, why? Or if they're not, why? All right? So, let us see the sets that we have over here. We have X is the set of colors in the rainbow. زين? And Y is the set of days in a week. زين? For X is the colors in a rainbow. I have no idea what they were. زين? When I was younger, I used to remember them: red, blue, green, yellow, purple, orange, violet, something like that. زين? المهم, they're colors. All right? And Y is the set of days in the week. فعندنا Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. All right? Obviously, these two are not equal sets. For them to be equal sets, they have to have the same exact elements in each. Here we have different elements between both. So these two are not equal sets. زين? So part A, not equal sets. ما يخصهم في بعض. These are the days of the week, and these are the colors of a rainbow. They have nothing to do with each other. They're not equal. Let's look at part B. So part B, we have X is 2, 4, 6, 8, 10. And Y is a positive integer, a positive even integer, and x is less than or equal to 10. So we're going to start with the first positive number we know, which is 2. And then a positive even integer, so 2. بعد ال 2 the even integer is 4. بعد ال 4 is 6. بعد ال 6 is 8. Because it said positive, so we're starting from 2. 4, 6, 8, up till 1, up till 10, and there is an equal sign as well. So it is equal to 10 as well. So this is 10. Now if you notice, this entire set is equal to this entire set. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Hence, these are equal sets. All right. So for a set to be equal, all the numbers have to be, all the elements have to be, like every element of the first set has to be the same as every element of the other set. So here we can say x is equal to y. Very simple. Come on. Moving on to the next question. Which of the following statements are correct, or which of the following are correct statements, given that this is A? So there's a new symbol here that I did not talk about, and we're going to talk about right now, which is this symbol. It looks like the letter C. This symbol basically means proper subset. All right? Or just simply subset of an element. Okay? So a subset or a proper subset, and then what does it mean? It means that it is a smaller set that is included within a larger set. For example, let's say we have the numbers 1, 2, 3, 4, 5, 6, 7. Okay? The proper set of this would, let's say this is 1 and 2. So these are both sets. And then let's call the first one set A. And let's call the second one set B. All right? Here we can say that A is a subset of B. ليش؟ لأن the numbers, the elements 1 and 2 are both available, 1 and 2 are both available in the larger set. Since these two are available, we can call them as a subset of B. This is what the symbol means. يعني there's a smaller set which is a part of a larger set. All right? The difference between a proper subset and a normal subset, a subset is going to be given like this. And the only difference between these is this one can be given when A is equal to B. بما معناه, we can say B is a subset of itself. We can say that. But B is not a proper subset of itself. زين؟ يعني, in other words, here, this is if the two sets are equal, you are saying this is a subset of the other one. It is correct, but they're equal. So it is not a proper subset. When they are not equal, when it is only a partially a part of it, like in the case here, A and B, this is where you would call it a proper subset. All right? Now, coming back to this point, an example of something that would not be a subset, let's say C is equal to 1, 2, 10. All right? In this case, we have a value that is not inside. Actually, let me just highlight. We have this value 10, which is not in this set. It does not exist. So we cannot say that C is a subset of B. C is not a subset of B. And this is how you would write not a subset. All right? So that's what it basically means, what subset means. In other words, معناته إذا عندكم شيء صغير نفس الأرقام نفس الاليمنتس لازم يكون يعني a subset of شيء ثاني كبير اللي يكون فيه نفس الأرقام فقط. That's all that this means. So let us solve this question now. Then let us solve this question now. Inshallah, all of these notes will be sent on the same channel, on this same meeting, yani in the Teams chat. As soon as I'm done, I will export it as a PDF and I will upload it here and you'll have access to them. All right, so these notes that I'm writing down now. Now, which of the following are correct statements? Given A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A. I'm not going to write it again. We have this to be A, which is the numbers from 1 to 10. So is 3, let's look at them one by one. 3, we have it here. 3. 4, we have it here. 5, we have it. 7, we have it. 11, we do not have 11 here. ما عندنا 11. So this is not a correct statement. This is not a subset. Same thing again. 1, 1, 2. Let me use a different color. 1, 1, 2, 2, 3, 3, 4, 4, 10, 10. Yes, all of these are proper. So this is a correct subset. 8. Just the number 8. Is it a subset of A? Remember, for this to be a true statement, this has to be a set as well. The number 8 by itself is not a set. If the number was like this is considered a set. This is not a set. So this is not a set. All right. For us to have a subset, it has to be 2 sets. Therefore, this is not a set. So this is also wrong. Okay. If you want this term to be correct, we had to write it as like this. 8 is a subset of A. لأن this way we are defining 8 as a set. So remember, 8 is an element of A. All right? 8 is an element of A. It is not a subset of A. زين? 8 itself is just an element. It's a number. It's a part of it. But it is not a subset. Subset is only for sets. Okay? Now, let's continue. Question 8. Write down all the subsets of the following sets. Number of subsets formula 2 to the power n. هني we have to write all of the subsets of any given set. Let's start with the number 5 because it's simpler. You would think that you only have one set, which is 5, but there is a concept I did not explain. There is something called the null set. All right, this is a null or void set. What does this mean? It means an empty set. يعني ما في شيء فاضي. يعني something like this. An empty set. It has nothing. So a void set is the subset of every single set. Every set in the world has a void set, has a set that has nothing in it, because nothing always will exist somewhere, you know? So this empty set is called the null or void set. It is usually given by the symbol phi, all right? Sometimes you might see it just given as this. Keep in mind, having this and saying 0, this is not a null void set, زين? Or having this and saying phi, this is also incorrect. These are not empty. Okay? This is very important. When you have the phi inside the parentheses, it is not this now has become a normal set. It is not an empty set anymore. For it to be a null void set, phi has to be written by itself, or the empty set has to be written by itself. يعني a set with nothing inside. So these are the proper all the subsets of the following equation. So A for part A, or the following set. So for part A, the set is A, B, and C. All right. There is, first things first, always we will write phi. This is the subset. A null or empty set or a void set known as phi is a part of it. بعدين عندنا A by itself. بعدين عندنا B by itself بعدين عندنا C by itself. These are all subsets of A, B, and C. And then we're gonna have A, B, and we're gonna have A, C, and then we're going to have B, C. These three are also all subsets. Then A, B, A, C, and B, C. And then we're also going to have A, B, C. And then these all are proper subsets, okay? These all over here are proper subsets. And then, in other words, using this. This is also a subset, but this is a just a subset. It's not a proper subset. It is using this. This is what I meant. In ABC, it is the same set itself. لأن it is a part of it, but it is not a proper subset. This is what you mean by a proper subset or an improper or just a normal subset. Okay, these are all subsets. Yes. Okay. Yani this is true about all of it. All proper subsets are subsets. زين. ولكن not all subsets are proper subsets. That's what you need to understand. تمام? So yeah, this is basically it, how you would write all the subsets of any given. Now, infinite and finite series. So we have two types of series or sets. And then we have a finite set and we have an infinite set. Finite means that the set will eventually close and you will have a specific number of values inside, and that's it. All right. So specific value, or in other words, we can say that the cardinality of it, n of, let's call this A, and then is equal to a real number. It's equal to an integer, n. And then, and it's equal to 5 or equal to 10 or equal to 20. You have an actual number for n. In the case of infinite set, this means that A is equal to a set that is never ending. It is open. It will never end. You will always have values in it. All right? It is non-stop. هني معناته ال n of A is equal to infinity. There is always going to be a number. There is always going to be an extra element. The elements will never finish. For example, let's do the first question here, part A. So you will see here very clearly the point I'm trying to make. Part A, C is equal to, let's write it down, X, where X is an element of Z, all right? Where Z, by the way, is the set of all positive or negative integers, and then, so that's what Z is. Z is the set of positive integers. Sometimes it's written as I, sometimes as Z. I believe this is given to you in the notes if you want to go and see what all the letters mean. With practice, you will get better at it and you will memorize most of them. Back to the question. الحين عندنا X is an element Z, so it's an integer. زين, starting from -2, but it's greater than, not equal. So the next value will be -1. The next value will be 0. The next value will be 1. The next value will be 2. The next value will be 3. The next value will be 4. We will never stop. ليش؟ لأن ما عندنا limit. We just know it's going to be greater than -2. We know that it starts from -1 basically, but it will keep on going forever until you reach 1,000, and then you're going to reach 1 million. And then it keeps going. So the question asks if it is a finite or infinite set. So this is going to be an infinite set. All right. Part B, P in this case, is an element, is X, where X is a multiple of 5. فبنبدأ by 5. زين, a multiple of 5 means يعني it's divisible by 5. يعني 5 times 1, 5 times 2, 5 times 3, 5 times 4. Okay? فعندنا 5, بعدين 10, بعدين 15 بعدين 20 بعدين 25 بعدين 30 بعدين 100 it never stops again. So this is also an infinite set. It's a never stopping set. زين. So if I ask you what is the cardinal number of an infinite set, how would you answer me? I want to see if you guys are paying attention. I want you guys in chat to answer me this. I want the cardinal number of part A or of part B. What would be the cardinal number or the cardinality? Yalla, wake up, work a little bit. Yes, exactly. Thank you very much, Meta. It is infinity. The cardinal number of an infinite set is always going to be infinity because it is never stopping. You will have infinite number of values. Thank you. So moving on, C. How do you know we have to start from -1 for part A? It is mentioned here that it is greater than -2, not greater than or equal to. It just says greater than -2. So what is the next integer that is larger than -2? What number comes after -2? It is -1. -2 is not included, so we start from -1 and then we keep going. So -1, 0, 1, 2. This is why we started from -1. Okay, part C. The set of constants in the English alphabet. The set of constants in the English alphabet. We have 26 letters in the English alphabet. 26 letters. We have 5 vowels, which are A, E, I, O, and U. And we have 21 consonants. And all right, which are the remaining letter. So now you guys tell me, before even I have to write this down, is this a finite or infinite set? It's a finite set, exactly. Why? Because we already have the cardinality of the consonants. Then we know that we have 21 consonants in the letter. So we know that the set of alphabets A, let's call it, and then it's gonna be B, C, D, F, going until we reach the letter Z. And we know that the cardinality of A is going to be equal to 21. We know that we have 21 elements in here. So we can already say, without even writing them it all down, that this is going to be a finite set. تمام؟ لأن the letters, the consonants in the English alphabet are going to finish eventually. They're not always continuous. بالمنطق as well. All right? Let's go move on to the next question. Fill in the blanks using the symbols subset or not a subset. It's very simple. We did the same exact idea earlier. So if we just look at each one by itself. So we have part A. And then we have part A. It's a bit too big. Part A is 5, 10, 15, 20, 25, 30. We want to know if this is a subset of 10, 20, 30, or 40. Now you guys tell me, since we already did an example, is this a subset, yes or no? Is 5, 10, 15, 20, 25, 30 a subset of 10, 20? Yes or no? Insane. All of you are saying no. Someone said yes, but then deleted instantly. It is not a subset, all right? Remember, we are looking from left to right. We are looking at this compared to this. Insane. So it is not a subset. Why is it not a subset? Very simple. There is a 5 here that isn't here. There's a 15 here that isn't there. And there's a 25 here that isn't there. Insane. This is why this is not a subset. If we look at the next one, part B, it says 2 and 4. Is it a subset of an empty set? Is 2 and 4 a subset of an empty set? There is nothing inside the empty set. Nothing exists. So it's not a subset. Very simple. Just simply look at 2. Is 2 available here? No, it's not. So it's not a subset. That's how you would check. The last one. The last one now, which is X is an even. Let me just write it down here again. So X is an even negative number. Let's write that in. This is given in the set builder form. Let's write it in the roster or the rule form so that we can understand it better. X is an even integer, is an even negative number, sorry. فمعناته it can be -2, -4, -6, -8, all of these. زين? These are all considered negative integers, or sorry, negative numbers, and it goes up to negative infinity, all of those numbers. And then, are these, and it keeps on going, are these a part of X, where X is an integer? يعني basically X is anything from minus infinity, -10, -9, -8, until 0, 1, 2. It is all the possible positive and negative numbers that do not have decimals. So is this a subset or no? Is -2, -4, -6, -8, all the negative numbers, a subset? Yes, it is, because this has all the numbers negative and positive. This has all the negative even numbers. So all the negative even numbers exist in all the rest of the numbers. So this is a subset of that. All right? Again, you need a little bit of logic to understand some of these. But with practice, you guys will get better and better at this. Tamam? Any questions so far about the first worksheet so we can go and move on to the second one? Any specific concept that was not clear? Let's see here. Then I'm going to just do a separate document for the second worksheet so it can be a bit easier to follow. Now, so we have the word kingdom. Then I should not have copied this with the answers, but we have the word kingdoms. Let K be the set of the letters of the word kingdom. Find K. Then find K. What does K mean? First, K, before even solving, is what? It's the set of the word kingdom. So we have the letter K, we have the letter I, we have the letter N, we have the letter G, we have the letter D, we have the letter O, we have the letter M. They are all unique. So this is kingdom. So how can we find K? It is basically kingdom. And then, yes, these sessions are all recorded. So this is part A simply. We just found K. Part B, find the cardinality of K. Okay, this is just a revision of worksheet 1, all of it basically. Cardinality. Cardinality, we're going to count 1, 2, 3, 4, 5, 6, 7. We have 7 numbers of elements inside the set. And then any 3 subsets of K. Okay, I want to see if you guys understand what subsets are. No 2 answers should be necessarily the same, then there is a lot. I want you guys to give me at least one subset. Each person, I want you guys to get involved and give me one subset of the word kingdom, or of the set K, I should say. Give me one subset of the word, of the set K. Come on. Okay. Iman wrote this. So part C. Empty set, which is correct, or phi. This is correct. Someone wrote K and I. This is correct. Someone wrote K by itself. This is correct. Someone wrote K, I, and N. Remember, you have to put in the parentheses. And these are all, you guys are all correct. D, N, and G is correct. Everyone that has wrote, everyone is correct. Okay, these are all considered subsets. You can consider anything as subsets. It has so many subsets. M, K, and O is correct. Can I repeat the subsets? انزين. So subset معناته you have specific, like I explained earlier, they have to be a part of the main thing. So let's look at K and I. They are a part of this main thing. So this is a subset. It is correct. Let's look at the letter just K. it is also just here, just K. So this is also a subset. It's correct. Let's look at Ki and N. Ki and N. Here we have K, we have I, we have N. So this is also a part of the subset, so it is correct. Phi, or empty set, is a subset of all the sets. All right? This is what a subset is. Someone wrote MKO. Okay, MKO, MKO. Zain? Remember, the order does not matter if you write K first, M. Yani this set is equal to this set. Zain? K, M, O. Order does not matter at all in sets. Zain? So if we look at MKO, Zain, if we go back up here, we have the letter K. Zain? This became a little messy. Let me remove it a bit, some of the colors. So we have the letter K. All right. We have the letter MKO. We have the letter M over here, and we have the letter O over here. So yes, this is also a correct subset. This is the whole idea of subsets. All right. Now, let's go on to the next question, which talks about the power set of the following sets. All right. The power set is the same idea as subset. The power sets are the same idea as subset. However, what does power set mean? Power set means all of the subsets. That's all this means. Power set, all it means is all subsets. Every single type of subset you can think of, that is what power set means. I'm not going to go through all of them. I'm going to do for part B only because it's a short and small one. So for part B, it will be the subsets are, the first one is phi. Okay. The second one is 1. The next one is 2. And the next one is 1 and 2 together. And all of this is going to be within its own set. Then remember, this is a power set. So this has to be a set as well. Okay. So this is the power set. This whole thing from here till here. This is a power set. So it is a set within a set basically. And then عندكم sets inside the subsets, all inside every single one, and they are all within one set. All right. So we can write this as either brackets, or you can also write this as phi, which is the null or void set. This is what a power set simply is. You guys can practice the others by yourselves. It's the same exact idea. Let's go to number 3. Given 3 sets A, B, and C, find the following. Now, I did not explain union and intersection and intersection in general. Then let us get into that right now. The union of 2 sets. Let's take simple sets first before we solve this question. I'm going to move this down. So we have 2 symbols. We have this symbol, which is union, and you have this symbol, which is intersection. So this is union, and this is intersection. To remember them, it's very easy. Union, the letter U, intersection, the letter N. Okay? So when we say, let's say we have 2 sets. Set A is 1 and 2, and set B is 3 and 4. Okay? So union, all that union means is we're gonna combine these 2 sets. So we want to combine A and B. Let's actually make B 2, 3, 4. And then, so A union B is going to be equal to a set that has all the numbers in A and B. So we have 1, 2, and B we have 2, which we already mentioned, so we're not going to write again, 3, and 4. And then this is what A union B basically means. We're going to have all the values in both sets written down, but we are not going to write down repeated values. Intersection is going to be slightly different. It's going to be very different, actually. Intersection means what is common in between both of them. So union is all, and intersection is common. تمام. So how are we going to write this down? We're going to look at whatever is similar. So we're going to look at 1. Is 1 available in B? No. 2 is available in B? Yes. 3, is it available in A? No. 4, is it available in A? No. So the only thing common between these two sections, these two sets, is the number 2. So 2 is the A intersection B. This is the whole idea. This is how you use union and how you will use intersection. All right? Very straightforward. So now we can start solving the question. So here we're given 3 sets, A, B, and C, all have their own numbers. Of the following, find the following. So we want to find A union B and B union A. Obviously, A union B is going to be equal to B union A. They are the exact same thing. Okay, instead of saying you're combining A with B, you're going to write B first and then A. So what it would look like is this: B union A, and like the example above, it's going to be 2, 3, 4, 1. Then a 2 is already written. So it's the same thing, just the order is changed. But they are equal sets because order does not matter inside of sets. And then, same thing with the intersection. B intersection of A is also going to be equal to 2. Then if you look at B, what is similar in B and in A? It's the number 2. So A union B is equal, and A intersection B is equal to B intersection A. Tamam? Now let's solve. A union B. We are given that A is equal to 3, 6, 9, and 12. Right? And B is 2, 4, 6, 8, 10. Okay? So we are trying to find union. So we want to find A, U, B. All right? We're going to look at all the numbers and write them one by one. Let's start with A. We're going to write 3, 6, 9, 12. And we're not going to write repeated. 2 is not repeated, so 2. 4 is not repeated, so 4. 6 is repeated, so we're not going to write it. 8 is not repeated, so 8. And 10 is not repeated, so 10. So this is the final answer for A union B. B union A will be exactly the same. I'm not going to go through that. All right. Same thing now. It says B and C. So we have our B over here. And C is given to us to be equal to 1, 5, 9, 13, 17. 1, 5, 9, 13, and 17. Okay? Again, very simple. B union C is going to be equal to, since we have union here, we're just going to write them all again. 2, 4, 6, 8, 10. We're going to write all the numbers of one of them. And then we're going to write the non-repeating numbers here. So 1 is not repeated, 5 is not repeated, 9 is not repeated, 13 is not repeated, 17 is not repeated, nothing is repeated. So we are going to write it this way. Now, that is B. We're done. This is the entire set. C says A intersection B and A intersection C. So the first two values again, part C. Okay, so this was part A. This is part B. This is now part C. All right. So first things first, we're going to do A intersection B, which is equal to, we have to look at the common numbers. 3, is it available here? No. 6, is it available here? Yes. So 6 and 6. 9, is it available here? No. 12, is it available here? No. No. So the answer is simply going to be just 6. All right. Very straightforward. Tamam? 6. And now we're going to do the exact same thing again for A and C. Oops, what am I doing? A, and then we're going to copy paste it down here. A and C. And they want us to find whether there's an intersection. Again, same exact idea. Nothing is new. A intersection of C. This is going to be equal to, let's see. Is 3 available here? No. Is 6 available here? No. Is 9 available? Yes, 9 is available between both. Is 12 available? No. So the intersection is simply going to be 9. All right? And this is how you find the intersection. Now, we can do the part D says, part D, I'm just going to copy paste it from here. Part D is A intersection B union C. So this is what we're going to do. We're going to first look at what's in brackets. Always we will solve what's in brackets or parentheses first. نفس in math, we're going to solve what's in parentheses first. Then we will do the intersection. So we're going to do A intersection BUC. And we're going to write the answer of BUC here. We already found what BUC was. This is BUC from part B, B union C. So we're going to look at A intersecting this set. What is A? A we had earlier is this. This is A. Zain. So A is this, and BUC is equal to this large thing. So we want to find the intersection now between these two. Take our highlighter. Let's go through them one by one. Intersection means they are the same. So let's look at 3. Is 3 any of these numbers? No. 6. Is 6 any of these numbers? Yes. There's a 6 over here and a 6 over here. 9. Is 9 any of these numbers? Yes. There's a 9 over here and 9 over here. 12. Is 12 any of these numbers? Nope. So what do we do? This is going to be A intersection of C, B union C is going to equal to 6 and 9 only. All right. Again, B union C is what's in parentheses. We're going to do that first, which we did earlier in part B. And then intersection will be A intersection all of the new set that has been found from BUC. And then you're just going to compare each set. It's very straightforward and very easy. Now, there is one more question I want to add to this, even though it's not here. The intersection between B and C. All right. I want us to solve extra question. Extra. B intersection C. Again, if I get B and C, this is B. All right. And this is C. So what does intersection mean? Intersection means that we need to find the common values in between. So intersection, all right? We need to find the common. Get our highlighter. Is 2 available here? No. Is 4 available here? No. Is 6 available here? No. Is 8 available here? No. Is 10 available? لا. ما في ولا رقم مناسب. There is not a single number that is the same in each element. So what do we say? The answer to this is phi. This is where you use the empty set. Exactly. This is phi, or you can write it as empty set. There is no intersection in between them. There's nothing common in between them. We cannot say that, okay, this is equal to 0. لا, لأن that means the number 0 is common, but we don't mean that. So we put in phi, or we put in the empty parentheses, meaning that it is the answer. There's no comparison in between. And that's pretty much it. Now, let's look at subtracting and adding. It looks like today we're just going to be going through week 1, but it's important because this is basically like 10% of the exam. So it's very important to know all of this. More like 20% of the exam. It's 10% of the mark, but 20% of your exam. So it's important we go through this. And inshallah, from next session, which is tomorrow, we're going to start with combinations and permutations. But I want to make sure everyone understands all of these, especially when they're referring back to it. All right? Don't worry, we will have more than enough time. So given U is equal to A, B, C, D, E, we're given U, we're given A, we're given B. we need to find the following: A minus B and B minus A. And then, now, how do we subtract in sets? All right. First, let us say we have this A. We're going to just solve the question directly. We have A is equal to A, B, C, D. As you notice, we don't have any numbers. Then, and B is equal to B, C, D, E, F. All right. So we have A, B, C, D here, and we have B, C, D, E, F, and B. So we're going to do A minus B. So A minus B. What does that mean exactly? We are going to look at the common values. Then we're going to look at the common values of A and B. So we have A, we have B, we have B, we have C, we have D, we have B, we have C, we have D. These are the common values. And we are going to remove them completely from A. And then, since A is the first number before the minus, we are going to subtract from A. So we are going to remove all the common values, and we will be remaining with just the letter A. This is what subtracting means. We don't care about the E and F. We just want to remove the values from A. The same exact thing will happen for B. And then, so this is for A minus B. Let's say we want to do B minus A. All right. For B minus A, again, it's the same purple highlights. All right. It's the same exact thing. But now we have B that is first. So we're subtracting from B. So what will be remaining is just E and F. In this case, only A was remaining. So this is going to be equal to E and F. All right. This is what subtracting means in the world of statistics or in the world of set theory. Tamam? Very simple, very easy, very straightforward. You just look at the common things, the intersection you could say between them, and you will remove it. And depending on which one is first, yani if A is first, you're going to put whatever is remaining from A as the answer. If B is first, you're going to put whatever is remaining from B as the answer. And that's pretty much it. Now, part B, A inverse and B inverse. Now, I did not talk about inverses at all because I was hoping I would explain it with the Venn diagram. It will make it a bit more easier. But we are given here the total set. Then the total set is set U. Set U is given U, which is A, B, C, D, E, F, G, H, I, J. So it's the letters A to J. A is a subset of U and B is also a subset of U. All right? So let me just write this down again. Actually, I'm tired of writing this down. Let me just do this, make my life a bit easier. So we have U, which is A, B, C, D, E, F, G, H, I. And then we have A. Then we have A, which is A, B, C, D. Tamam? So if you notice, A, B, B, C, C, D, D. This is the set A. This is the set A, يعني this within here. This is set A. صح ولا لا? A prime, or let me give it a different color, A prime would be everything else that is not A. This usually means not or prime. Or there was another word I'm trying to remember, the complement or complement. Then these can be all used for the same thing as, or A inverse as well, or inverse. Then there's a lot of ways you can call this. Basically, when you see A like that, not, معناتها it is all the values that are not in the original set. So A naught will be all the values that are not in the original set. So it is going to be A, F, G, H, I, J. This is what A naught means. The same exact concept applies to B, obviously. So if we take this again and we copy paste it down here, and we take B, B is B, C, D, E, F. All right. we take B. If we compare these two, what is similar? B we have here and here. C we have here and here. D we have here and here. E is here and here. And F is here and here. Keep in mind, this has to be a full subset of a proper subset of U. All right. We cannot find the prime or inverse or complement without having one part be a subset of another part. So what will be remaining? A, G, H, I, and J. So B prime is going to be equal to A, G, H, I, J. This is what the definition of prime, inverse, or complement, or even just not A naught or B naught. This is what it means when you see the symbol, the power of 1 يعني. This means that it is the inverse or the opposite or the complement or the prime of the original set. All right. So now let's go to the actual question itself. The question says, or the questions, a lot of them say this. B is asking for A naught and B naught. زين. So we just write A naught and B naught, which we already did earlier. So this is A naught. This is A naught. And this is B naught. All right. So this is for part A. Okay. Part C, or part B, I mean. For part C, they want A naught union B naught. Now you will apply the exact same concepts that we applied before. These are new sets. Same thing. This is union. Union means we're going to write them all without repeating anything. So A prime union B prime is simply going to be equal to A. Let's write, actually not in order. Let's write everything from A prime. So E, F, G, H, I, J. All right. And now the remaining ones from B. So A is not repeated, G is repeated, H is repeated, I is repeated, J is repeated. Okay. And that's it. This is A prime. Let's do intersection, or D. Intersection, again, same thing. We're just going to highlight. We're going to look at the things that are common. So E, is it available down here? No. F, no. G, yes. We have G here and G here. H here and H here. I here and I here. J here and J here. The union is going, the intersection, I mean, is going to be G, H, I, J. All right. And that's it. This is how you would solve such a question. And then let's go to the next one. If there's still a lot of questions to do, but it's fine. Let's go to the next one. Now, in a group of 150 students, all right? It was found that 60 students liked cricket, and then 50 liked tennis, 70 football, 30 liked cricket and tennis, 20 liked tennis and football, 25 liked football and cricket, and 30 liked none of these games. Find the number of students who liked all three games. Now, we have to go step by step here to understand all the processes that we have. So we know that U meaning the total, everything, the number of students, U is going to be equal to, or I should say the N of U is going to be equal to 150 students. And what are the sets? We have tennis. We have tennis. We have what else? Cricket. Football. That's it. We have tennis, cricket, and football. All right. So we're going to have to create sets for each one. زين. We're gonna have to create sets for each one. This is not a set in itself. This is just the options that we have. We have tennis, cricket, and football. So the first one, we found that 60 students liked just cricket. So cricket by itself, زين, is equal to 60 students. 50 tennis by itself is equal to 50 students. And football by itself is equal to 30 students. Sorry, 70 students. Then 70 students. If you notice, these 70 plus 50 plus 60, it has to add up to 150 students. طبيعي. لأن we have a number of players that like cricket, a number of players that like tennis, a number of players that would like football. And it could even be more than 150, less than 150. But here we are considering that these are all the students that actually like sports in general. And then, so when you add these all up, it's actually going to give you a number of 180. And then, but why is it 180? Because there could be a player that likes both cricket and tennis. So these sets do not have to be equal to 150 total. But the number of students is 150 students. And then, now, let us color code all of this so that there is no confusion. We have cricket, which is 60. We have tennis, which is, what was it, 70? It was 50. And we have football, which is 80. Let's move on. 30 of them liked cricket and tennis. So if we're talking about cricket and tennis, زين, they're equal to 30. زين. So the people that like both cricket and tennis, there's 30 of them. And the people that like football and tennis, زين. So the people that like football and tennis, so T and football, is equal to, how much was it? Football and tennis? 20. All right. And 25 liked football and cricket. So cricket and football is equal to, what was it? 25. And 30 students liked nothing. Okay. 30 students liked nothing completely. So we know that a total of 120 students of the 150 like sports, 30 do not like sports. All right. So here we can start building our systems, our actual final systems. Let's look at all the cricket values first. So one, we need to find out how many students only like cricket. All right. How many students only like cricket? How can we do that? We're going to add the students that like other sports as well. So we have 30. Then, so for cricket, then we have 30 plus 25 is equal to 55. So 55 of cricket, 55 students that love cricket, love other sports. So how many left from the 60? We're just going to simply do 60 minus 55 equal to 5 students that only like cricket. All right? These are the students that only like cricket. We can do the exact same concept for each one. So let's go for T now. For tennis, we have 50 students, right? Total. We know that the total is 50 students that like cricket. That like tennis. We know that 30 of them like tennis and cricket, and 20 of them like tennis and football. فكم بيبقى لنا؟ how much will this be? This will be 30 plus, it's not 25, it's 20, sorry. So 30 plus 20 is 50. So how many just like tennis? only tennis. We have 50 students that like tennis minus 50. So this is going to be equal to 0 students only like tennis. There is no student that only likes tennis. They have to like tennis and another sport. And now let's look at the last one, which is football. All right. Football has 80 people that love it in total, but let's look at the comparisons. So we have football and tennis, which is 20, plus we have football and cricket is 25, which is equal to 20 plus 25 is 45. 45. So we have a total of how many players? 80 that love football minus this 45 which love both. So this is going to be equal to 35 students love both only, I mean, football. So we found the number of students that love each sport specifically. Then we found that. However, we need to find the number of students that like everything. All right? That like everything. We need to find the number of students that like everything. How can we do that? So we know that we have cricket and tennis, 30, and 25 that are cricket and football. And we have, let me just actually take all of these and bring them down with me. Do that again. Okay. So we have cricket and tennis equal to 30, tennis and football equal to 20, and cricket and football that is equal to 25. Then we know that these many people like 2 sports at the same time, but we need to know how many of them like 3 sports at the same time. So we're gonna have to compare each and every one with the other. So the football and football here, and then we have football and football here. We have 20 and 25. So the number of students here is 20. We have the number of students here as 25. And that means we have a difference of 5 more players that like. Second. Okay. We have 5 people more that will like cricket than tennis. Then, same thing, if we are looking at cricket and cricket, we have 5 people more that like the cricket. This is cricket and cricket. We have 5 people more that like cricket and cricket over here. Sorry, cricket, tennis and football. Sorry. So that like tennis and football over here. And over here, we're going to notice. So let me highlight these for you. So when we're looking at the red values, we're only looking at 30 and 25. And then we're going to do, so we're going to subtract. We're going to see how many difference is between them. We notice that there's 5 people more. And then we did the exact same thing here. We looked at football and football. And then we looked at this for football and we looked at this for football. We noticed that it's 5 people more again. We're going to do the same thing now again. We did for football. We did for cricket. We're going to do the same thing for tennis. For tennis, there's 10 people, and then 10 people that like cricket and tennis more than football and tennis. And then 10 people more. All right. So how are we going to do this now? We are going to subtract all of this then from each other so that we can find out the value of the number of people that like all 3 sports together. زين فعندنا هني 5 that we'll take out of this. We'll take out 5 from here. We will take out another 5 from here. Again, for the red, we're going to take 5 out. بيبقى لنا كم؟ 20. زين. We're going to take out red 5 from here. We're going to take out green 5 from here. بيبقى لنا how many? بيبقى لنا instead of 25, we're going to be left with, I'm not going to write this in black عشان ما يكون في confusion. This is 20. This is going to be 25 minus 5 minus 5 is 15. And we're going to do the same thing here. We're going to remove the green. 5 people. And we're going to remove the purple, which is 10 people. Sorry, this purple is 10. It's not 5. This purple is 10. Okay? So we're left with 15. 15. And we're going to do the same thing here. We're going to remove 10 and 5. We're going to notice that we also have 5 over here. So what does this mean? Aslan, we did not have to remove from the last one. We only had to remove from one of these the number of people that are being removed. ليش؟ لأن we are going to consider that the number of people that are liking all the other sports together. This is the common number that like all the sports together, which is 15. I think I went too much into details here, into depth, يعني. There is an easier way to solve this, which I will go over now. And then I feel like I've complicated things more than made things easier. This part, I want you guys to understand, it's not a part of the question, but I wanted you guys to know if they were asking how many students only liked a specific thing, how you would do it. This is how you would do it. Here in this question, it says even here, find the number of students who like all 3 games and use A, union B, union C. What does that mean? That we are going to use A, union B, union C, and then we're going to find the n of it all, which is the cardinality of the number. This is another way of doing it. So we know that U is going to be equal to 150 students. We know that A is equal to, let's say A is the number of, instead of A, let's just name them as they were. Let's call this T, or let's call it C. We started with C, let's call this C. Then C is the number of students that like cricket. And as we know here, the number of students that like cricket is a total of 60 students. So total of 60 students like cricket. And where's the other letter? T, a total of 50 students like tennis. And where is it? F. Then F is equal to 80. 80 number of students that like what you call it, football. So these are not the actual F and C and T. This is the N of C, because this is the number of students that like football, not the actual students. This is the N of T, and this is the N of F. Okay. Now we also have the number of students. So N of C. So when we have C plus T plus T, all right? We have C plus T, which is the students that like both of these. Then I want to actually solve this in the easiest way I can think of, which is by doing a Venn diagram so you guys can see the bigger picture. لأن أحس with too many numbers, you guys are going to be confused. And at the same time, I will get to explain what a Venn diagram is. Then, so that there aren't too many numbers so you guys don't get too confused. Okay. So this is what we will call a Venn diagram. عندنا احنا الحين 3 situations. عندنا students that like football, and then students that like tennis, and then students that like actually we have more than 3. We also have the students that like nothing. But we know that there's a group of 150 students. And then so this is U. Let's call this U, which is 150 students. And then meaning there's 150 numbers throughout of this. يعني لو عندنا dots, there is 150 dots throughout all of this يعني if we wanted to number them, we have from student number 1 to student number 150 throughout this entire block of paper that we see here. All right. We have 30 of them that are outside. We have 30 of them outside, 30 students. Why are they outside? Because they like nothing. They enjoy nothing. They're the students that do not like anything, any sport, any of the sports, that have liked nothing. So they're outside. Now we're going to draw the 3 circles, and then we're going to combine them properly. Then, where's the last one? Green. Right? We have our 3 circles. We know that a total, now if we're just talking about the total, we have 60 cricket, 50 tennis, and 80 football. So 80 football, 50 tennis, and 60 in cricket. All right? Remember that these are the total numbers. So we also have a combination, which we're going to have to subtract to find out the combination. Now, if we look at these one by one, which is the C, T, the combinations over here, I'm going to put them down here so I can just look at them very quickly. We have this, and we also have this over here. And then, so we know that C and T are overlapping by 30. So we know that C and T have an overlap of 30. C and T is the red and the purple. So we're going to remove 30 from here, بيبقى لنا 20. And we're going to remove 30 from here. We're going to be left with 30. All right? And we're going to have them overlapping. I will tell you why I wrote it like this. So they're going to be overlapping. Now, زين. And this 30 is outside of the overlap, and this 20 is outside of the overlap. Let me make this a bit bigger. زين. So we have 20 and 30. تمام? And this 80 is here. Let's keep the football on the side for now. So, and we have 30 in between. So this is also 30, which is the intersection of both. This is 30 because it's in both circles. So 30 plus 30 is 60, which is how much we have in cricket. Let me copy paste this down as well so we can stay referencing to it. So again, we have 60 total people in cricket. So it's 30 plus 30, which is 60 in total. And in the purple circle, we have 50 in total, which is 30 plus 20. Now let's add the combination of C and F. All right. We know that there's 25 shared between them. So this is going to be 30 minus 25, which is going to become 5. Because the 25 is going to be shared down here. Let's just make this bigger. Okay. So we have 25 shared over here. Because we have 25 shared here, we have to remove 25 from the 80. So 80 minus 25 is going to be equal to 85 minus 80 minus 25. مخي ضرب for a second. Yeah, it's 55. All right. 55. تمام. Now this is shared. Again, if you do 55 plus 25, you're going to have the total number, which is 80. And if you do 30 plus 5 plus 25, you're going to have a total number of 60, which is the total number of students that like cricket. إنزين? Again, now we have 55 here. We also have a sharing between this. If we move this a bit more to the side, إنزين? We have sharing that is happening between the 55 of football and tennis. We know that 20 of them like it. So it is going to actually look something like this now. How do I do this? Something like this. Right. But the purple is going to be much smaller. So let me just make this larger. Do not get confused. I'm just going to redraw it. And then it's the same exact circles. I'm not going to change anything. But so you guys can get the idea. This is going to be much smaller. And these two are going to be much larger. And the purple is in between here 30. And this 20 is going to go away. Why is this 20 going away? Because it's also sharing 20 with the football. So we're going to have to remove the 55 now as well. Zain, we're going to have to remove the 55 as well and subtract 20 from it. So 55 minus 20 is equal to 35. Zain. If you notice the 35 and 5, this is what we calculated earlier here, the 5 and 35. It's the same exact thing. This is just through the Venn diagram. If you notice another thing, all right, we are trying to make sure that everything, oh, sorry, here, this 30 is not shared inside, it's shared outside. So it's going to be more like, let me try to move it better. Move this to the right. It's going to look something like this. There we go. And the 20 is only between the purple. Make this a bit smaller. Bring this a bit more to the middle. The purple, which is the tennis, is only going to be between both the red and the green. It's not going to be outside because it doesn't have any, there is no people that actually like tennis by itself in this case. So the 30 is being shared with the red and the 20 is being shared with the 35 that are here. Now, if you notice one thing, we have this big gap in the middle. We have this big gap in the middle. Zain? So there has to be students that are sharing some of these sports as hobbies. Okay, there are sports that they like. We know that a total of 120 students are actually into sports. Why? Because 30 students are not into sports. So we know that the total is 120. All right. So if we subtract 35 from it, the number of people that like football, بيبقى لنا 85 students. Then, so this is just the people that like football. Then we will be remaining with 85 students. And then if we subtract the number of students that like cricket, which is 5, cricket, we're going to be remaining with 85 minus 5, which is just 80. Zain. So the middle part, it should be equal to 80. We have 30, 20, and 25. 30 plus 20 plus 25. Zain. 35, 25. Let me just check one thing really quickly. 80, 20 plus 30 is 50. 25 plus 5 plus 30, 60. Okay. So again, we're going to be remaining with 80. So we're going to have 80 students that don't only like football or only like cricket. There has to be 80 students that like both or more, that they can either like within this region in the middle. And so the way we can figure this out is we're going to have, if you subtract 80 minus this total thing, how much is this? It's 20 plus 30 plus 25. صح ولا لا؟ زين. It's 20 plus 25 plus 30. زين. So 20 plus 30 plus 25 you're going to notice that this is 80 minus 75. معناته we are remaining with 5 people. This means that from each part over here, from each part, this is very important, that we're going to take from each shared part, we're going to be taking 5. And we're going to be adding it to the middle. So this is going to be 5. This is going to be 5. And this is going to be 5. This is basically going to make the middle have 15 in total. So we took 5, 5, and 5 from each side. And now we are remaining with 15 in the middle who like all 3 sports. And of course, because we took 5 from each one, we're going to have to add 5, remove 5 from each one over here. So this was, I forgot what they were. I should not have erased them all. So this is 20 is going to become 15. This is 25, which is going to become 20. And this is 30, which is going to become 25. All right. I know you guys, it might be a bit overcomplicated what I did. Zain. Oh, the football is 70, not 80. Okay. Thank you. I just realized that. Thank you. 70. So if this is going to be 70, then this is going to be 70. So if I do the math again, let me go back to all the previous steps that I did. Remove this, remove that, remove that, remove this, and then. So let me erase this now. Let me erase this. Sorry about that. Let me fix this very quickly. So we said that it is 70. So we're going to have 10 less. In football, we had 35, so it became 25. I don't know why I put 80 up here then. This is going to be 70. And then this is going to be 25 students. Then this is 25 students. Yeah, everything else is okay. So this is going to be 25 students. Now, it is not minus 35, it is minus 25. And then minus 25 is going to give us minus 95. 120 minus 25 is 95. And then now we are just trying to calculate how much is in this gap in the middle. Okay, that is the whole idea. So 120 minus 25 football players is going to be 95. 95 minus 5 is 95 minus 5 is going to be 90. All right, it's going to be simply 90. Now we're just going to subtract again 90 from, like I said, the group that is combined over here. So minus 20 plus 25 plus 30. So it's going to become 90 minus 75. So it's going to be equal to 15. Earlier it was 5. I even made a mistake in the calculation. So it's 15. So in the middle, we're going to have 15. How did we get this 15? We took 5, not from this. We took 5 actually from the main one because we already calculated the edges 20, 30, and 25 from earlier. But we need to make sure that all of this adds up to 150. This is the point that I'm trying to make. So we know that there's 15 students that have the same common sport, which is all 3 sports. We have 25, 30, and 20 that have shared sports, 25 and 5 in a single sport, and 30 students that like no sports. When you add up all these numbers, it has to be equal to 150. So what we did is we did the reverse engineering of it. يعني we went the opposite way. We wanted to find the shaded area. We did 150, the total, minus the 30 students. So let me write that as well. So we did 150 minus the 30 students that don't want any sports, minus 25 that are only playing football, minus 5 that only like cricket, and then minus 20 that like both cricket and football and tennis, minus 30 that like tennis and cricket, minus 25 that like cricket and football, and that will give us the remaining who like all 3 together. All right. So this is what the Venn diagram is. I know this might have not been very clear. It's because I was mashing up a lot of concepts together in one, but I will explain the Venn diagram a bit more, and maybe when you go back to this question, you will have a better idea of what the Venn diagram is. I am going to skip most of these questions. They are very straightforward. All right. I want to do one more Venn diagram question so that you guys understand how to use a Venn diagram. Now, we have this question and this Venn diagram that was given with it. And then, so we have this Venn diagram shows how many students like tennis and football. Answer the following questions using the diagram. How many students like only tennis? Only tennis. And then, so we want the students that want like only tennis. The people that like only tennis are within this shaded area. Then this is the shaded area. These are the people that will only like tennis. So how many people are there? There are 17 people, right? So it is 17. All right, this is what the Venn diagram is. Let's look at the next question. It says that only like football. Only like football is everything outside of the common area. Everything that is outside of the common area, which is this entire area over here, which is what? It is 15. So how many people like football? 15. Like both tennis and football. يعني they like both of the tennis and the football. Meaning they're in the middle. They're in the shared area. They like both, which is 10. Now, I'm going to copy paste this down again. لأن the next question asks, does not like football by itself. It just says does not or do not like football. What does that mean? The people, we know the people that like football are within this circle, right? We know the people that like football are within this circle. Okay? These are the people that like football. They're inside here. Okay? Inside this orange circle. So we know that everyone inside this place likes football. So we're not going to look at them. We're going to look at everybody else. Who else is outside here? It's the people that only like tennis, which is 17. Plus the people that like nothing, which is 9. So it is going to be 17 plus 9 is 26. So 26 people do not like football. Do not like football or tennis. So now we are talking about these two circles. All right? We're talking about these two circles. Anything outside of these two circles are the ones that do not like tennis or football, which is just the number 9. So this one is just 9 people. So this is how you would use a Venn diagram. And then some basic concepts I want to just clarify before we end the session about a Venn diagram. A Venn diagram, there are some operations you can do using sets. And then, so if you have any Venn diagram like this within a square area, right? We have, let's say we have 2. This is 1 and this is 2. All right, you have 2 sets. Let's call them A and B. So this is set A and this is set B. Okay? And this is the universal set or the set outside, which is encompassing A and B. A union B would be A and B if they have a union in between. All right, if we have a union in between, the union part is going to be all of this. The entire set itself, the whole shaded area here, this is going to be A and B, or A union B, okay? This is known as A union B, so this is A union B. Do not confuse with the U up here. The U up here is not union, this is the letter U for universal set, okay? So this is how it would look like if they ask you for A union B. So you'd want all the numbers that are inside. Now, let's take the same example, but instead of union, let's say we have intersection. All right? Intersection. The intersection will be like where they are actually intersecting in real life or in the Venn diagram, which is the shared common area in between. Remember, intersection means common. Union means all. So this blue area, this is where the intersection will be. And the last thing I want to explain is the complement, which I explained earlier as well. The complement, which is, let's say, we're looking just at A. We want the complement of A prime. And then it will be the entire shaded area that is outside of the A itself. So it's going to be this entire shaded area surrounding the A circle, all right? So this entire thing is the complement of A prime, or also known as the complement, all right? So let's take this example, union. So it's basically the opposite, yani it's not A. So whatever is in A is the opposite of that is going to be the complement. So let's take another example. Let's say we know A union B is this purple part, but let's say we want the complement of the total complement of A union B. So instead of going for the purple shaded area outside, it is inside, I mean, it is going to be the purple shaded area outside. So it's going to be this shaded area over here, this entire part outside here, this whole shaded area. All right? This is the complement of a union, for example. Tamam? So I hope this was useful, this session. I'm gonna conclude it and hopefully here. Sorry if I took a bit too long explaining the concept of the Venn diagram. I was trying to make it easier, but I feel like I made it a bit more complicated. But do not worry, you see how basic Venn diagrams are. You just need to understand the concept and you will be fine. My recommendation is always practice as much as you can. The worksheets, you guys have a lot of worksheets that you can practice from.